6.3 Vectors in a plane. So first, what is a vector? So many quantities of geometry and physics such as area, time, and temperature can be represented by a single number. So if I tell you what the temperature is, 85 degrees, everybody knows what we're talking about. Like we have a clear picture of that in our mind. But some things need both a force and a velocity, a magnitude and direction. That's what a vector is. It lets you know like how fast you're going and which direction you're going. To represent a vector, we use a directional line segment like here. Right, so this is a vector that we're going from P to Q. Where you start is your initial point, and the direction you're going is your terminal point. And we always start at the initial point, so PQ is the name of this vector. If you were going the opposite direction, QP, this will be the vector QP. Right, so it's always where do you start to where do you end. How long the vector is, like you see how like these have lengths, that's the magnitude. So the magnitude is equal to how the length of the vector. We'll talk about how to find that later. And then we usually donate it with this formula right there. So that lets you know how long something is. So something like PQ, the double like absolute value, lets you know how like, the magnitude, which means how long is it, like it's the size of it. And then the direction is just like literally which direction it's going. Like this one's going this way. These are two different directions. We're doing an angle thing. This will be in quadrant 1, this will be in quadrant 4. So two different directions. Vectors are usually done by lowercase boldface letters. So you see like this, or you also see it since it's hard to bold, like on paper. A lot of times they'll put a little vector, like little vector head on it. Okay, let's get into it. Let U represent the direction line segment from P to Q, and let V represent the direction line segment from R to S. I've shown that. Show that U is equal to V. So the way we do like a vector, if we want to find like RS, is we're going to do tip minus tail. Right, so if we're doing RS, the tip of RS is S. So we're going to do S minus, and we start R. So it's going to be 4, 4 minus 1, 2. And you just subtract the corresponding parts and you get 3, 2. You can see those match. It's also known as a component form of a vector when you put it like in standard form, like from the origin to whatever the point is. We're going to learn more about it next. So component form of vectors is represent a vector in standard position, which just means you're starting from 0, 0 and you're going to whichever direction you want. Right, so if I give you a point like this, your initial point is 0, 0 and your terminal point is the point you list. So that's all component form is. So when they give you v1, v2, you start at 0, 0 and you go to v1, v2. If they have a 0 vector, which is a thing, that means that it's given by the point 0, 0. So how do you find a component form of vector? Tip minus tail. As you can see here, if they have 2 points, P and Q, then it's going to be Q minus P. So tip minus tail. The magnitude or length of a vector, you just do Pythagorean theorem basically. Now if you have it in component form, you just do Pythagorean around those two components. So it's like that. If the magnitude equals 1, we call that a unit vector. And if magnitude equals 0, then that has to be a 0 vector. Okay, so let's do an example. Find the component form of and the magnitude of a vector that has an initial point of 4, negative 7 and terminal point of that. So the component form of the vector is just going to be the tip minus tail. So that's going to be, the tip is the terminal point, the tail is the initial point. So we're going to do negative 1, 5 minus 4, negative 7, and you just subtract the corresponding part. So negative 1 minus 4 is negative 5, and 5 minus negative 7, that's double negative, makes a positive, is 12. So if you wanted to see like what this vector looks like, it's negative 5 and 12. So it's like, that was bad. It's like this. That's where that vector is. So that's my vector. Negative 5, 12. And it goes left 5, up 12. If I want the magnitude of that vector, well, all we're doing is figuring out how long the vector is. So it's going to be like, you can make a little right triangle here and go, well, this is negative 5 and this is 12. So you can do a squared plus b squared equals c squared. Or just use the magnitude formula, which is the square root of the first one squared plus the second one squared. So here we're going to get 25 plus 144, which gives us square root of 169, which is 13. So that's how long that vector is, 13. Vector operation. So if you have a vector, you can do a couple things. You can multiply by a number. We call that a scalar multiplication. Scalar just means a number. So it's not a vector, it's just like a value. So you can multiply by a number. So you can see here, here's your vector v. You can multiply by 1/2, makes the vector half as long. You can multiply by 2, makes it twice as long. You can make it a negative, flips the direction. A negative vector flips it. And you can multiply by fractions. So that's scalar multiplication. You multiply a vector by a number, it does the same thing you would expect a number to do. How about vector addition? Well, when you add vectors, like I have these two vectors here, when we add them, we add tip to tail. So when we add vectors, you have a vector like this and a vector like that, you want to move this guy up to the tail there. And then that's the vector you added. That's a and b, this is a plus b. You can see it right here, right? They have u and v. You add this guy to the end of that guy, like right there, and then the resultant vector as your u plus v. How do I do that mathematically? Really easy. You just add the corresponding parts. So if you're going to add two vectors, right, my vector u here plus my vector v there, you just add the x's and you add the y's. Simple. If you just multiply by a number, you just multiply, so k times u, you just multiply each value by that number. So vector addition and multiplication is super easy. So let's do a couple examples here. So this is going to be scalar multiplication. We'll multiply 2 by this vector. So it's just 2 by the vector -2 and 5. So literally just multiply both things by it. So you get -4 and 10. B, we have vector subtraction. So we have w, 3, 4, minus v, -2, 5. And then you just subtract corresponding parts. So that's going to be 5, because the double negatives. 3, I should show the work. Right, it's 3 minus -2. And then it's going to be 4 minus 5. So we get double negatives of +5 and -1. C, you can combine the two ideas. You have vector v, -2, 5, plus 2 times w, 3, 4. So just like everything else, order operations, just multiply that out first, the -2, 5, plus 6, 8, and then you just add up the corresponding parts. So 4 and 13. So mathematically, vector addition and multiplication is one of the easier things we have. Here's some rules about it. So commutative property still works if you add the 0 vectors. So there's a lot of the same rules still apply. This normal mathematics. So we have distribution, we have community, we have associative property, we have add by 0, we have inverse. All the kind of same rules apply. Interesting one here is magnitude. You can pull out a number, constant. How about a unit vector? A unit vector is just like, I want a vector. So like this here, this vector is going this way. A unit vector, I want a vector that's going the same direction, but only has a magnitude of 1. Hence known as a unit. So all we're going to do there is get the vector and divide it by its magnitude. If you do that, you get a unit vector. That's what the formula right here is saying. Or right here, actually. Or that one. That's how you find a unit vector, right? So you have a vector going that way, and you just find a unit vector. That means the same vector, but only a length of 1. Just get that vector and divide it by how long it is. So let's do an example. Find a unit vector in the direction of -2, 5 and verify the result as a magnitude of 1. So the formula for a unit vector is just v over the magnitude of v. So remember, the way you find the magnitude is this formula. You take -2 squared plus 5 squared. And in that case, we're going to get 4 plus 25, just square root of 29. So that's my magnitude of my vector. So all we're going to do here to find this guy is we're going to get our vector. And then we're going to divide it by the magnitude, square root of 29. So we're just going to split it to each one. -2 over square root of 29, comma, 5 over the square root of 29. And that's our unit vector. So that's a vector going in that direction, but only has a magnitude of 1. And you can check your work by plugging this in and see if the magnitude does equal 1, and it will. So now let's talk about component form of a vector. So we could write a vector as a summation of its unit vectors. So a lot of times you'll see a vector like this, a vector written as AI plus BJ. All that means is this is essentially the x value, and that's essentially the y value, like over here. Like 2, -5, that would be like 2i plus minus 5j. We call this component form of a vector. And all it is I means the unit vector going going left and right, the x value, and then j means the unit vector going up and down, the j value. So a lot of times we'll write a vector like this because it's a little easier to write. So let u be the vector with initial point that term 0.93. Write u as a linear combination of standard vectors ij. So we want to write this in terminal form. So first, let's just find the component form. Let's find our vector. So remember the way we do this, tip minus tail. So we're going to do -1, 3 minus 2, -5. So we'll get -1 minus 2 and 3 minus -5. So we get -3 and 8. Right, so that's my vector. If we want to write it in this form, we're just going to go, my vector is -3i plus 8j. There we go. Got the component form of a vector. Right? It's just the same thing, just writing in a different way. Now we have this new form of writing a vector. We could do the same operations. If I wanted to add and multiply vectors, we're just going to plug it in. So 2 times u, which is this guy, minus 3 times v, which is this guy. We're going to treat it just like we always do, just like normal mathematics. You distribute, right? This is scalar multiplication, so you get -6i plus 16j. I can do math. Distribute this negative here, so you get -6i plus 3j. And then here, add up like terms. So you get -12i plus 19j. So that's our vector. It's the same thing as having a vector that was like this. It works the exact same way, right? This is the component form. If I wanted to find the magnitude, it would be the exact same. Take the square root of -12 squared plus 19 squared, right? All the same things apply. It's just this is written in component form, which is a little easier to write for most people. Directional angles, right? So here's our vector. So it goes like this. We actually find what angle it's going, right? Because it's just a tangent. It's just a triangle. So if you have a triangle, you can find the angle. It's just SOHCAHTOA. And in particular, remember if you have a point xy, we'll say this guy here is going from, we make a little triangle. We'll say this is A into our B component, right? And then AI plus BJ. Right, that's our vector. So it would go this way in our A, and this way in our B, and our X and our Y. How do you find the angle? That's just tan, opposite adjacent. So tan of the angle is going to equal to B over A, which is just the y component of the vector and the x component of the vector. And that's it. So let's find the direction and angle of some vectors real quick. So like for A, remember, if I want to find the angle of this, well, first let me do a couple things. Let's draw that one just to see it. So 1, 2, 3, 1, 2, 3. That's our vector, right? So if I want to try to find this angle here, all we're going to do is make a triangle. This is 3, that's 3. So that's just going to be tan of theta is equal to 3 over 3, where this 3 is the y version, this is the k version. So if you want to find the angle, just tan inverse it. And you get theta equals 45. If we did B, now we don't need to actually draw the thing. We have the formula tan of it. This formula is equal to B over A. So in this case, we have tan of theta is equal to -4 over 3. So we could inverse tan this. And we get theta is equal to, theta is equal to -53.13. Now the one thing is that we should check if it's on the right quadrant, because if it's not, we have to fix it. Because remember, tan inverse only does quadrant 1 and 4. So if you're in quadrant 2, 3, you do have to fix it. How do you fix it? You generally add 180 to get to the right spot. But -53, so where are we at? 3 and -4, 3 and -4. That is quadrant 4. and this angle, negative 53 degrees, would be around there. So yeah, that works. There's one more thing. We generally want our vectors to be between 0 and 360. So to fix this, we're going to find a cotangent angle, and we're going to 306.87. So that is our angle for that vector, 306.87. And that's the lesson.